In this video, we're going to start taking a look at some trigonometric or trig ratios. And in this video specifically, we're going to focus on the sine ratio. Before we do that, we need to make sure we understand the relationships with some sides and some angles within right triangles. We are going to be looking at right triangle trigonometry. So we have angle A, and we're going to label the sides of this triangle in relation to angle A as being a side that's opposite to the angle, adjacent to the angle, or the hypotenuse. Now, you're probably familiar with hypotenuse as being the side opposite of the right angle in a right triangle. So the hypotenuse is going to be opposite of the 90-degree angle. So here's the 90-degree angle. Opposite of that is your hypotenuse. Opposite will be the side that is across from angle A. So if we're looking at angle A and we're going to go across, that is going to be our opposite side. That leaves the adjacent to be the side that helps form angle A. Let's take a look at the other triangle here. Again, we have angle A is an acute angle. We have a right angle marked with the square in the corner. So across from that will always be your hypotenuse. If you go across from angle A, that side will be your opposite. And then that leaves the third side, which also happens to be a side that helps form angle A, to be the adjacent to angle A. So when we're doing any right triangle trig, you're going to have to be able to recognize in relation to an acute angle, which side of the triangle is the hypotenuse, which side will be opposite of the angle, and which side will be adjacent to the angle. And this is important because we have three different ratios that we use for trig ratios. We have sine, which is the length of the leg opposite the angle over the length of the hypotenuse. And we have cosine, which is the length of the leg adjacent to the angle over the length of the hypotenuse. And tangent, which is the length of the leg opposite the angle over the length of the leg adjacent to the angle. So these are all ratios, they're all fractions. You might see this written as O over H. You might see cosine written as A over H. And you might see tangent written as O over A. The O stands for opposite, the H is the hypotenuse, and the A is adjacent. So ratio is another word for writing a fraction. Opposite over hypotenuse is your sine ratio. Adjacent over hypotenuse is your cosine ratio. Opposite over adjacent is your tangent ratio. Also, on a calculator, or even in text, you will see these abbreviated. Sine will look like sin, but we pronounce it as sine. Cosine is just COS. And tangent is just abbreviated to tan, but we do read it as tangent. Some people also use the phrase so katoa to help remember the ratios. Sine is opposite over hypotenuse. Cosine, adjacent over hypotenuse. And tangent is opposite over adjacent. You may also see it written with the S, but the OH behind it as a ratio. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So this is your introduction to the three ratios. We're going to spend the next couple of slides focusing on the sine ratio. So again, the sine ratio is the opposite length over the length of the hypotenuse. And so we're looking at angle A. It's always a good habit to recognize where angle A is. Our opposite side is even labeled opposite for us here, is side BC. So the ratio here would be BC over the hypotenuse of this triangle would be side AB. And since we're talking the lengths, we're going to use notation for length. So the length of BC over the length of AB. If we had actual measurements, we could put the length, the actual measurement in here, which is what we will do on the remaining triangles. So here we have, write the sine ratio of each acute angle as a fraction in simplest form and as a decimal rounded to 3 decimal places. Let's start with sine of A. So I'm going to circle A. I'm going to identify which side of this triangle is the hypotenuse, and it doesn't matter which angle I'm working from. The side across from the right angle is always the hypotenuse. Now, when it comes to angle A, the side across from it is the opposite side. And then the 36 is going to be the adjacent side. But for sine, just as a reminder, sine is opposite over hypotenuse. So we aren't even going to need to use the adjacent side for finding the ratio for sine of angle A. Since sine is opposite over hypotenuse, the opposite of angle A is 15. The hypotenuse of the triangle is 39. Simplest form of this ratio, I can divide both the numerator and the denominator by 3. This reduces to 5 over 13. And then as a decimal rounded to 3 places is 0.385. If we were to use a table of trigonometric ratios, it would include decimal values out to 3 places. Also, you may find it in a standardized test out to 3 places. So it's good practice to have you see the ratio written both as a fraction and as a decimal. Now let's take a look at sine of angle B. Now, I know I'm going to need the hypotenuse again, so I'm not going to erase those markings. But let's focus on angle B this time rather than angle A. So for angle B, that's going to change some things. For angle B, the opposite, the side across from it, is going to be the 36. And since we're working with sine, I'm just going to identify the opposite. I have the hypotenuse. We don't need to worry about the 15. So for sine of angle B, opposite of angle B is 36. The hypotenuse is 39. Again, both of these values can be divided by 3, so this fraction will reduce to 12 over 13, or 12/13. And as a decimal, this is approximately 0.923. 3. And we have found the sine ratios for the acute angles in this right triangle. We have one more triangle that we're going to look at. Again, I would always recommend you find your right angle and you identify the hypotenuse as your first step, because it does not matter which ratio you are working with. There's only one side of the triangle that can be the hypotenuse for any of the ratios. Sine of angle R. So let's identify where angle R is. Again, sine is opposite over hypotenuse. So we want the side opposite of angle R, which is the 18. So we're going to have the ratio of 18 over 82. In simplest form, both of these are divisible by 2. That reduces to 9 over 41. And as a decimal, that is 0.220. I'm going to erase my markings so that I can focus on angle S. Angle S has an opposite side of 80. So this ratio will be 80 over the hypotenuse is 82. Simplify the ratio and we have 40 over 41. Both values can be divided by 2. And as a decimal to 3 places, we have 0.976 approximately. So just to let you know, or just to remind you, always identify which side is your hypotenuse, identify which angle you're working off of, and then identify which side would be the opposite, and if needed, which side would be the adjacent, before you start writing the ratio of the side lengths for that particular angle.